So we will look into the basic concepts of geometric sequence. Now, imagine this type of number 2, 4, 8, 16, 32, and so on. If you look into the pattern, you will get that we are multiplying 2 to the we are multiplying 2 and we are getting 4. Again we are multiplying 2, we are getting 8. Again 2, we are getting 16. Again we are multiplying 2, we are getting 32. So there is a pattern that every number is obtained by multiplying 2 with the previous number. Now going by that same logic, we can find out all the terms. Like after 32, it will be 64. Okay. So this kind of sequence is called geometric sequence. So in geometric sequence, what happened? Our nth term will be obtained by multiplying a constant ratio with the previous term. So if an minus 1 is the previous term, then we will obtain the next term by multiplying one constant to it. This constant is called common ratio. It is called simply common ratio. So if we know the common ratio, then we can go on generating the entire geometric sequence. Like in this example, 2 is our first term and we know that common ratio is 2. So we will multiply 2 with common ratio, we will get 4. Then we will multiply common ratio to 4 and we will get 8. And in this way, we can generate the entire sequence. So let us look into how to find the nth term in geometric sequence and how to calculate the number of terms if the number of terms are given and initial value is given and so on. So if we look into the common pattern, if we look into the general structure, so we will have a first term, right? A is normally, it is called first term. So we will see how to generate the geometric sequence. So A is called the first term. Now let us take R as common ratio. So we will write A1 as A. Then our second term will be first term into R. This is the second term. How we have obtained? We have multiplied the first term with the common ratio to get the second term. Similarly, third term will be obtained by multiplying R with the previous term. That is, AR is the previous term and we are multiplying R to it. And we will get AR squared. This is the third term. In this way, we can also write the fourth term. So what we will do? Our previous term was AR squared multiplied by R. So we will get AR cubed. This is the fourth term. Going in the same way, we can generate all other terms. And if you look into the pattern, we can also write the nth term. So nth term, which is denoted by A subscript n, is given by first term multiplied by common ratio to the power n minus 1. This is the nth term, which is very, very important. This expression is very, very important. So note it down. An, that is the nth term is equal to first term multiplied by common ratio to the power n minus 1. For example, let's say we have, so example 1, we have been given first term as 5 and common ratio as 2. So first term is obviously 5. Second term will be first term multiplied by 2. that is 10. Third term will be 5 multiplied by 2 to the power 2, because we know that nth term is given by a r to the power n minus 1. So third term will be given by 5 times 2 to the power 2. So one number less than what it is given, 3. So we will get 5 times 4, that is 20. Similarly, we can generate all other terms. In fact, if we write A4, we have to simply write 5 times 2 to the power 3. So we will get 5 times 8, that is 40. In this way, we can generate the entire sequence. This is how we can calculate the nth term. Let us see one more example. So example number 2. Example 2. Let's say it is given that our first term is 4. Our first term is 4. And a common ratio is, let's say common ratio is 2. And it is given that our fifth term, or okay, let us find out the fifth term given given these two parameters. So how to find fifth term? So we will write fifth term, that is A5, is equal to first term multiplied by common ratio to the power 5 minus 1. That is 4 2 to the power 5 minus 1. That is 4 2 to the power 4. And this will be 4 times 16. So this is our fifth term. 4 times 16 means it is 4, 64. 64 will be our fifth term. Similarly, we can find out sixth term, or any number of any term we can calculate by using this formula. Now we will look into the formula which help us in finding the sum of n terms of a given geometric sequence, that is geometric progression. So let's say we have been given 2 plus 4. Let's say we have to find out 2 plus 4 plus 8 plus 16 and so on. Let's say all the way up to 10th term. Then how to do it? The first thing is you have to find out the 10th term. So 10th term will be given by first term. We have seen this formula that nth term can be calculated by multiplying nth term with common ratio to the power n minus 1. That is, here it will be 9. So plug in the values. We will get 2 here as the first term, and the common ratio is 2. So 2 to the power 9. So we will get 2 to the power 10. That means we have to find 2 plus 4 plus 8 plus 16 plus all the way up to 2 to the power 10. So this entire number we have to add. Now manually it is very difficult. So there must be some formula which help us. Yes, that formula is, we will write like this. Nth term, sum to nth term is given by the first term multiplied by r to the power n minus 1 by r minus 1. So here A is the first term, R is the common ratio, N is the nth term up to which we want to calculate the sum. Now how we have derived it? Yes, we can derive it, that we will see later on. Right now, this is the expression that help us in finding the sum of n terms of a GP. Now, if we apply this formula to find out the given example, So here we can see that first term is 2, common ratio is 2, and n is 10. So our sum to 10th term will be given by 2, and here it is 2 to the power 10 minus 1 by 2 minus 1. That's it. No need to find the exact value. This is sufficient. You can write 2 to the power 2 multiplied by 2 to the power 10 minus 1. This is the sum of n terms of this particular GP. Now remember that common ratio may be positive, common ratio may be negative, common ratio may be integer, common ratio may be fraction. For every such scenarios, this formula is valid. Now, sometimes you will see this formula also, that Sn is equal to A 1 minus Rn by 1 minus R. So this is also okay. Normally this formula is used when R is less than 1. And the previous one will be used when R is greater than 1. Now, if the n term is infinity, that means if you want to find the sum up to nth term which is infinity, let us take n as infinity. Then in this scenario, sum of all the terms will become A by 1 minus R. Remember, this formula will be valid only when R is less than 1. Okay. So this is all about the geometric progression basics. Now, after this, we will see some examples related to arithmetic sequence and geometric sequence. Thank you.